So it turns out that I thought I'd recorded the first period's lecture today, but for some reason I couldn't find the file, so this is going to be a replay on that stuff. Hopefully I can go a little faster on this so that I can get it down into a reasonable amount of time. Okay, so I am doing 4.2, and what we're going to start out with is trig functions on a unit circle. So if you take a look at this example I have up here, you've got a point A whose x-coordinate is root 2 over 2, comma, y-coordinate is root 2 over 2, and it's on a unit circle, meaning that the radius is 1. Okay, the radius of that circle is 1. So what it looks like if you were to look at the triangle, okay, this is your point root 2 over 2, comma, root 2 over 2. So that means that this distance here is root 2 over 2, and that distance is also root 2 over 2. And the angle I'm talking about is that angle. Okay? And I hope you see that the radius is 1. Let me just go ahead and do that for you. So r squared is equal to root 2 over 2 squared plus root 2 over 2 squared, which is equal to 1. Okay, and so r is equal to 1. So if you look at it, then sine theta is equal to root 2 over 2, which is the same thing as saying it's equal to y over 1. Cosine of theta is also root 2 over 2, and from this triangle you can see that it is x over 1, and tangent theta is equal to y over x. Okay, so here are equations for sine, cosine, and tangent given a point x comma y on a unit circle. So the next thing we're going to deal with is what happens if the point is not on a unit circle. Okay, if it's not on a unit circle. So let's take a look at that situation there. So again, I think this lecture might be going faster than what I did in class, and that's only because for some reason the file wasn't saved. I have no idea why it wasn't saved. I hope it doesn't show up somewhere else in some other folder, because I'm going to be having to spend about another 15 minutes doing this lecture. Alright, so let's take a look at a circle with a point on it whose coordinates are x comma y. Okay, so that's my radius. This is x, this is y, and this is the angle I'm talking about. Okay, that's the angle theta. So from this right triangle here, you can see that sine theta is equal to y over r, cosine theta is equal to x over r, and tangent theta is equal to y over x. So this is the most general formalization of trig functions given a point x comma y on a circle. Okay, what we had previous to this is r was 1, and therefore these formulas became very simple. This one was the same, but these two were just y and x. Okay, so r is 1. Now the reason why I do this is that I don't particularly like the unit circle stuff that you might have studied in the past in order to find trig functions of angles like 210 degrees or 300 degrees or something like that. You had to memorize the unit circle and all that. I don't really care for that. I'm going to show you a different style to do that, okay? And that style is going to require you to know this acronym, all students take calculus, okay? And I'll explain to you what that means, okay? All students take calculus. So what this means is that if I take, let's say, a circle, and remember, an angle has an initial side, which is always the positive x-axis, and a terminal side. And if my terminal side is in the first quadrant, okay, then all trig ratios, that's what the A stands for, okay? This is all students take calculus. All trig functions are positive, okay, are positive. If the angle was, if the angle was in the second quadrant, so out here, so So this is the angle I'm talking about. Then only sine would be positive, and its reciprocal function. The reciprocal function of sine is CSC. Those two would be positive. And then you can extend it and you can see that tangent would be positive here and cotangent would be positive there. Cosine would be positive here and SCC would be positive there. That's what all students take calculus stands for, okay? So what I do is I combine this concept, okay, I combine that concept with the concept of reference angles to find trig functions of, some friendly angles like, say, sine 240. Okay, so let's say I want to find sine 240. Okay, which means that it's going to be in quadrant 3. That's 240 degrees. So the idea I need now, the concept that I need now is the concept of reference angles. Reference angles. Okay, or reference angle is a positive acute angle that the terminal side of an angle makes with the x-axis. Okay, so notice that it is positive and it is acute. So for the example I have here, remember this is what I want to find, okay, I want to calculate that. So for the example that I have here, this angle here is a reference angle and that is 60 degrees. That's 60 degrees. Alright? Because 180 plus 60 is 240. Now since this is in Q3, okay, that's in Q3, and since only tangent is positive in this quadrant, sine is going to be a negative quantity, and then you're going to do negative sine of the reference angle, which is 60 degrees. Sine 60, okay? And then from your friend's table, you should see that sine of 60 is root 3 over 2, so you answer over 5. Okay? And so that's the last example of the day, and I'm done.